Let's have a look at a very special number called pi, and by this stage you will know that if you take the circumference of a circle and divide it by the diameter of that circle, the number always comes out to be about 3.1. Now if this is done very, very accurately, you end up with a number like this, which continues on and on and on. Well, as far as anybody knows, they've never been able to find a point where it terminates. And this particular number is called pi. It's given the Greek letter pi. It's probably easy to write it just like this when you write it down. So there's the value pi. And we call it an irrational number. Now, very simply, an irrational number is one that you can't write as a fraction. Now, we all know that if we take a number like 1 over 4, we can write that as 0.25. If we take 1/3, we can write that as 0.333, and that keeps going on and on and on. These decimals here can be written as fractions, but pi can't be written as a fraction, so we call it irrational. And we do know that there are a couple of fractions that get very close to pi, 3 1/7 and 22 over 7. They actually get very close to pi, but they're not exactly pi. So that's why we call it irrational. Now, the important thing to notice in this section is that we're going to have a look at two formulas. One is the circumference of a circle formula, which is given by this formula here, that the circumference of a circle is made up of taking the value of pi out of your calculator and timesing it by the diameter of the circle. So if you know the diameter of the circle across here, and you times it by pi, you can actually work out the circumference. Now, the other thing to notice is that if you look at the diameter is 2 times the radius. I think you'll know that. Now, if that's the case, then the circumference is also 2 pi r. Why? Well, there's pi, and there's pi. There's 2, and there's the radius. So it's just another way of working out the circumference. Rather than timesing diameter by pi, you just times the radius by pi, but then you have to times it by 2. So let's have a look at some questions on the circumference of a circle. So just as a quick review, the perimeter of a circle, that's the circumference, the outside, that's exactly what the circumference is, the perimeter. So just like a square, if I drew a square like that, the distance around the outside is called the perimeter of the square. Well, with a circle, the distance around the outside is called the circumference. It's really just the perimeter of the circle. And it's given by these two formulas that we talked about just a moment ago. The circumference can either be worked out by taking pi and multiplying it by the diameter of the circle, or taking the radius and timesing it by pi, but then doubling it, because the radius is half of the diameter. Let's have a look at a couple of questions here that will help you to understand how this works. In this particular situation, we've got the circumference needing to be calculated, and we have a diameter, and it's got to be done to 2 decimal places. So the first thing we need to always do is to write down the formula. In this case, we're given the diameter. So we're going to use the formula C is equal to pi times the diameter. Now, pi is out of your calculator, so we don't need to write down a number for that. And in this case, the diameter is 6 centimeters. So when we multiply this out and we round it to 2 decimal places, we get 18.85 centimeters as the value for the distance around the circle, which is the circumference. In this question over here, we're given the radius. So instead of using pi d, we're going to use the formula, the circumference is equal to 2 pi r. Remember that the diameter is twice the radius. So it's just the same formula rewritten in a different way. So it's 2 times our calculated pi times our radius, in this case, 4.5 centimetres. Working this out with our calculator to 2 decimal places, we get the answer 28.27 centimetres. So there we go. They're very simple to do as long as you use the correct numbers and the correct formula. Let's have a look at one other idea in this topic. What do we need to do in order to find the diameter or the radius when the circumference is known? You'll notice the formulas start with the circumference, and we've got pi times d here. So if we've got diameter, it's easy to work out circumference. But what if we're not given diameter and we're given the circumference and asked to find the diameter, or likewise the radius? Now have a look at how we've rearranged this formula. Notice that I've got c equals pi times d. That's this one over here. Now remember, in algebra, if I want to get d on its own, I divide both sides by pi. So if you look at this, those will cancel out. So my diameter is c over pi. And there it is there. D is equal to c over pi. I'll just get rid of that big line. There we go. So let's have a go at applying this now and seeing how it works. Looks like I've deleted the working here. So I'll just rewrite that. Here we go. We know that D, here it is here, is now equal to c over pi, which was the formula that we needed. So we'll extend the page up a little bit so we can work this through. And here's our question. The circumference of a circle is 60 centimetres. What is the diameter? Well, here we go. We know that c is equal to pi times d. We can just substitute in c as, in this case, 60, which equals pi times d. And then rewriting this using our rearrangement, we can say that 60 divided by pi is equal to d. Just changing it around. And if we put that into our calculator, we get d is approximately equal to, remembering that pi is an approximate number, 19.1 to 1 decimal place. What about this one here? We need the radius now to 1 decimal place. Well, we don't really need to worry about rewriting the whole thing, but what we will do is we will keep our unrounded value of the diameter. So let's just change that. We don't need the diameter, we need the radius up here. There we go. We need the radius equal to, it will be our diameter. So we're going to write down what was in our calculated display. So it's about this, if you look at it correctly, 19.09859317. Now that would be about our calculated display. In fact, you could write your whole calculated display out if this wasn't it. Now we're going to divide this by 2, because remember the radius is half the diameter. The reason why we needed to write this out fully is if we write it down in too rounded a form, then the radius will be further away from the real number because of the rounding error here. So really, the bigger the number here before you round, the better it is to get an accurate answer. So in this particular case, we can round this now to approximately 9.5 to 1 decimal place. And going back here, we'll just put our units in centimetres. And that's how we can calculate either the diameter or the radius from this formula up here, knowing the circumference.